Bismillahirrahmanirrahim. Dear students, today we are going to derive an expression for a radius of an atom according to the Neal-Bohr. So the first thing that you must keep in your mind is that the Neal-Bohr derived the radius but only for the monoelectronic system. Monoelectronic system means the only elements that have a single electron, like hydrogen, helium +1 and lithium +2. It can't be applicable to those having the more than one electron. So let's start. We are going to discuss for an hydrogen atom. Let's suppose you have a hydrogen atom having a positively charged nucleus and one single electron revolving in its own shell, and the distance between these two particles is of the radius of that orbit, and as it is moving in a circular, so it is having a centrifugal force that is equal to the mv square by r. As both of these are the charged particle, so there must be a Coulomb force between these two particles, that is the force of attraction, that is also known as Coulomb force. And as according to the Coulomb law, it states that the force between two charged particles is directly proportional to the product of their charges and inversely proportional to the square of the distance between them, and 4 pi e naught is the constant. So we have an electron having a mass m, charge e, and nuclear charge is expressed by Ze positive. Z is the atomic number and E positive is the charge on the proton. So Coulomb force is equal to the Ze square by 4 pi e naught r square. As I explained earlier, that this is the Coulomb force that exists between the two charged particles, and the centrifugal force as it is moving in a circular path. So for a uniform circular motion, the both forces must be equal, that they must balance each other. So if we equalize both of these equations, like mv square by r is equal to Ze square by 4 pi e naught, as we have to derive the value of r, so we multiply r on both sides. Here it cancels, and here as there is a r square, so one of the r is cancelled and one is left behind. So then we separate the r from all other values by dividing mv square over here and r, like we cross multiply these two values, and so we separate the r, and here then r becomes that Ze square by 4 pi e naught mv square, like r goes over here and mv square comes at the place of r. So these all values are constant except the v square. V square is the variable, so we must know any kind of particular values for this v square. That comes from the postulate of Neal-Bohr regarding to the angular momentum. As you know that angular momentum is equal to the nh by 2 pi. So here we will find out the value of velocity v, and m and v r is as a whole is the angular momentum, but as we need the only value of v, so v is equal to nh by 2 pi. As here we need a v square, so we also take the square on both sides. V square is equal to n square h square, that is equal to 4 pi square m square and r square. Then we put the value of this v square in this equation. As it is in denominator, so here it comes in the form of reciprocal, like here n h square is at the numerator, but now as the v square is denominator, so n square h square also comes in the denominator. Then by cancel all the common factors like 4 m, here is a m pi square is a single pi, 1 pi cancel each other, similarly m cancel each other and the single m left behind, and the left expression is r is equal to Ze square by m r square, as here is r square and here is a single r, so one of the r cancel each other and we find out the value for the single r. At the end what we obtained that e naught h square n square and Z square pi m, that is equal to the r. So all of these are the constant except n. N is actually the number of shell, so we represent all of the constant with a single constant, that is a naught, and if we put the single expression over here in the place of all these constant a naught, so the overall r becomes equal to the a naught n square. By putting the value of n and any number of shell, we can find out the radius. Thank you so much.